So students, hopefully you are fine, and today we are here with a new video of short questions of chapter 2, which is a vector and equilibrium. So let's start. Define the terms unit vector, position vector, component of a vector. A vector whose magnitude is equal to 1 is known as unit vector. A vector that describes the location of a point with respect to some origin is known as a position vector, and the effective value of a vector in a specific direction is known as component of that vector. Vector sum of three vectors gives a zero resultant. What can be the orientation of the vectors? If the three vectors are represented by the sides of a triangle, then the sum of these vectors will be equal to 0. Like the vector A, B and C, here the resultant of vector A and B will be equal and opposite to the vector C, hence resultant vector will be 0. If one of the rectangular component of a vector is not 0, can its magnitude be 0? Explain. No, its magnitude cannot be 0 because the magnitude of a vector is equal to the sum of the square of its component. So to make its magnitude 0, all of its components should be equal to 0. Can a vector have a component greater than vector's magnitude? No, a vector cannot have a component greater than vector's magnitude. It can be equal or less than the vector's magnitude because part is always less than the full. Components other than rectangular components can be greater than the vector's magnitude. Can the magnitude of a vector have a negative value? No, the magnitude of a vector cannot be negative because magnitude of a vector is equal to sum of the square of its rectangular components, and square gives the real and positive values, hence magnitude of a vector is always positive. If a plus b equals to 0, what can you say about the components of the two vectors? If a plus b is equal to 0, then components of both vectors are equal in magnitude but opposite in direction. Under what circumstances would a vector have components that are equal in magnitude? If the vector makes an angle of 45 with the horizontal axis, then both of its components will be equal in magnitude. Is it possible to add a vector quantity to a scalar quantity? No, it is not possible because quantities of same nature can be added only, whereas vectors and scalars both are different physical quantities. Can you add 0 to a null vector? No, we cannot add 0 to a null vector because quantities of same nature can be added only, and 0 is a scalar quantity and null vector is a vector quantity. Hence, we cannot add 0 to a null vector. Two vectors have unequal magnitude. Can their sum be 0? Explain. No, the sum cannot be 0. Their sum can be 0 only if both vectors have the same magnitude and opposite in direction. Otherwise, their sum cannot be equals to 0. Show that the sum and difference of two perpendicular vectors of equal lengths are also perpendicular and of same length. This can be shown as. How would the two vectors same magnitude have to be oriented if they were to be combined to give a resultant equal to the vector of same magnitude? If the both vectors are represented by the sides of an equilateral triangle in cyclic order, then the resultant represented by the third side of the triangle will be equal in magnitude to both of A and B. In other words, if vector A and B makes an angle of 120 with each other, then the resultant will be equal in magnitude to both of A and B. Suppose the sides of a closed polygon represents a vector arranged head to tail. What is the sum of these vectors? Their sum will be equal to 0. Let we have 5 vectors A, B, C, D and E. If we add them by head to tail rule, then resultant of vector A, B, C and D will be equal and opposite to E. Hence, net resultant will be equals to 0. If all the components of vectors a1 and a2 were reversed, how would this alter a1 cross a2? If all the components of vector a1 and a2 are reversed, then a1 cross a2 remains unchanged, and this can be shown as. Name 3 different conditions that could make a1 cross a2 equals to a null vector. If a1 or a2 is null vector, if a1 and a2 are parallel to each other, if a1 and a2 are anti-parallel to each other. A picture is suspended from a wall by two strings. Show by diagram the configuration of the string for which the tension in the string is minimum. The configuration of the picture can be given as. To make the tension minimum, the factor sin theta should be maximum, which is equals to 1 and possible only when theta equals to 90. Can a body rotate about its center of gravity under the action of its weight? No, a body cannot rotate about its center of gravity under the action of weight, because the weight force passes through the axis of rotation. Hence, moment arm becomes 0, and when moment arm is 0, then torque becomes 0. Hence, no rotation. So, hopefully students, you have understood all these questions, and if you like my video, then watch it, share it and subscribe my YouTube channel. We will upload the next video soon. Thank you.